Okay, so for this, we have all the temperature data for Miami and for Los Angeles. One thing to remember, even though this looks like it might be an X column and a Y column, or an X row and a Y row, this is all just temperatures. So this is one variable. So this would be your X list for Miami. And then you could do your list for Los Angeles. So it asks which one has the least variability. So what I'm going to do is I'm going to make a box plot for Miami. And I'm going to make a box plot for LA. And I'll go through the steps of how to do that, but I'm going to use my calculator for this. You could do it by hand, but the calculator will be faster. So to start on your calculator, you're going to add a new document, and you're going to add lists and spreadsheet, or data and statistics. So you'll do new document, and then data statistics. In the top, make sure that you label your column. So I would have your column and you call it X up here, and then enter your data. And then I just did both at the same time, and I did a Y column and I entered my data. So my X was my Miami and my Y was my LA. You actually don't have to make a box plot with it. You just have to find the range, because that would be the variability. So you want to know, oh, whichever one has the smaller range has the least variability. So you can do your one variable stats after that. So for one variable stats, that's going to be menu and statistics. And then you're going to choose one variable stats. Once you do that, you hit enter, and you want one variable, and then you're going to name your X list, and I'm going to pick that for X. So when I do that, I'll pick my X list and I'll say OK. And what I find is that the one variable stats gives me my minimum of 60 and my maximum of 83. So, well, actually, my maximum of 87. So I've got my minimum of 60, my maximum of 87, and I would just do 87 minus 60. So you might actually say to yourself, why would I bother when I could just find the minimum of 60 and the maximum of 87 and say that I have a 27-degree range? So that's fair enough. You don't necessarily need to bother with that. But if you're using the calculator and you want to do a box plot, or you want to see it and kind of obvious for you, then you could do that. So I'm going to go ahead with my normal strategy, because I've got everything in. And this time I would pick my Y list instead of my X list, and I will find out what those results are. So what I find is my max is 74 and my min is 61. So I have 74 minus 61, and so that looks like a 13-degree range. So which is the least variability? Los Angeles. How did I arrive at my answer? That's key. Explain how you arrive at your answer. You could show this kind of work. You could say that I found the range and picked the one that was smaller. So as long as you have something to support. That's the one. So here we go. We have scatter plots representing the relationship between the number of peanuts a kid eats and the bowling score. Okay, so first, before you even look at the graph itself, I want you to think common sense. And I immediately think there can't be a relationship between the number of peanuts you eat and your bowling score. I also look at the graph and see there really doesn't look to be a pattern. It looks to be all over the place. So this is a great question. So no bowlers eat peanuts. That seems kind of silly. Students who eat more peanuts have lower bowling scores. Well, as peanuts go up, nothing really happens with bowling score, so no. Students who eat more peanuts have higher bowling scores. No, same thing, nothing really happens. There is no relationship, or almost no relationship. Okay, our next one. This is where we need to be reminded of a few things. I had a lot of students ask me about this. What is your R, which is your correlation coefficient, and what is your residual? So let's start with that correlation coefficient. The correlation coefficient is the letter R, and on a scatter plot, you will see data following a trend line. So here we go. Here's our trend line, and all our data is going up, and you might say, oh, looks like a positive slope. Okay, you could also see data that starts up high and goes down low. I'm going to make this a little more varied, and you could see your trend line, and you would say, oh, this is a negative slope. So here we go. This would be a positive R value or a positive relationship, and this would be a negative R value. Okay, so the tighter that relationship is, the tighter those dots come in, the closer our correlation coefficient is to 1 or -1. So that R value, that correlation coefficient, is either going to be a maximum of 1 and a minimum of -1. So it's going to bounce around in between there. So if you see the data really tight, close into that line, then it would be a coefficient closer to 1 or -1. If it's not tight, if it's kind of scattered all over the place, it's going to be like 0.7 or -0.7. So here, which one would not be a good fit? Well, it's a good fit if the data is closer in. So if it's going to be close to 1 or -1, it's a good fit. So right here, -0.93, that's pretty close to 1. That would be a pretty good fit. A correlation coefficient of 1 is a perfect fit. It means it's literally your scatter plot is right on the line. The line is the line of best fit, and it covers every piece of data. Now the residual plot is kind of, it's fun. So all of these data points are a certain amount away from the predicted line. So these are the actual points. This is what happens in real life, but they're either higher or lower than the main line. So we have a way of plotting that. You have your X and your Y value, and the residual plot plots your X values. Notice you keep your X, and it plots something called the residual. And the residual means how far away is it from that main line. So it's either positive distance away if it's above, and it's negative distance away if it's below. So this one, if you look at, it's down 1, 2, 3, 4, 5, that would be 5 paces or 5 spaces away from the main line on the negative side. This would be 1 space away on the positive side. So if you're looking at your data, you can tell where it is based on the actual scatter plot. So we learned in class that when a residual has a pattern, see the U-shaped pattern here? It is not a good fit for the scatter plot. When the residual is random, see how this is very random all over, it is a good fit for the scatter plot. So in this case, we'd be looking at choice 3. Our next one, middle school survey of students. Okay, it says, of the students who spent more time playing games on their tablets, what percent are boys? So there's 2 things you have to find. It wants to know what percent are boys, and we want to know of the kids who played games on their tablets. So these kids spent more time playing games on their tablets, a total of 192. That would be your total. That would be your whole, 192. So this is your whole. And the boys are 138, so you would have your boys over whole. So you've got 138 over 192. You just do your quick division, and when you do that, you've got your 138 divided by 192. You get 0.718, and it says what percent. Remember, you move your decimal place over 2. You multiply by 100. Percent means per 100. So 72%, so choice 3. Our next one, this one asks you to construct a box and whisker plot. This, is not multiple choice. So they're going to want to see the list, which means you can check your work in your calculator, but you do need to do this by hand. So we'll just walk through the by hand part. So I'm going to find my lowest one, 66, then 71. The biggest error here is usually just in missing a data point. 72 and 73. And then we jump into the 80s. It looks like 82, 85. If you're on a Regents, I would highly recommend checking this on your calculator because you can see all those spots. Even if you're just doing this now, I would be checking it on the calculator. So you have your 89, 91, 92, and 95. Okay, so now the way you do this is you find your median. So I have 85 as a median. If there's 2, you take the average of the 2. Well, the average of the 2 would be 85. So your median is 85. So put that up here. And now you find your median of the lowers. So I'll go through again. I'll switch to green. 1, 1, 2, 2. Your median of the lowers is 72. I'll do that. Go ahead and do that in green so you can see how that lines up. And then I'll switch and I'll go to black for the top. So 1, 1, 2, 2, your median is 91. Again, you're approximating a little bit. We'll go ahead and we'll put this in here. And then our highest value is 95. So put that up here. And our lowest value is 66. Those are our whiskers. So this is what our box and whisker plot would look like. Okay, next one. The box and whisker plot shown below represents the number of magazine subscriptions sold by members of the club. Which statistical measures do points B, D, and E represent? So I need to locate them. B, D, and E respectively. That means in order, so from left to right kind of thing. So B is not the minimum point. B is quartile 1. It might be nice to know what each one is first. So B is quartile 1. This is your min. This is your median or your quartile 2. This is your quartile 3. And this is your max. Okay, so you have your minimum, median, and maximum? No, because the first point is not the minimum. First quartile, median, and third quartile? No, because your second point is not the median. First quartile, third quartile, and maximum, that sure looks like it is to me, so choice 3 it is. Okay, what does the correlation coefficient of negative 0.975 on a linear regression indicate? The slope is positive. No, because it's a negative correlation coefficient. One variable causes the other. When the relationship comes out to be pretty close to 1 or pretty close to -1, you know there's a relationship. You do not know if one variable causes the other just from the numbers. The scatter plot shows no association of the variables. It shows a very high association of the variables because no association would be scattered all over the place, and it would be a correlation coefficient like around 5 or something. So this would not be the case. One variable has a strong relationship with the other. That would be what it shows. Problem number 8. This is probably the one I saw most kids about. Use the data to write the regression equation y equals ax plus b. That's the first thing that messed people up. Y equals mx plus b is what we're used to. You'll see different choices in there. Knowing that a is the same as m, or the slope is what you want to think about. Round all answers to the nearest hundredth. So what you're going to do is you're going to key this stuff in, but you need to know what to key in. You want to key in your x, which is your tutor hours, and your y, which is implied, it's your raw test score. So your x and your y, and then you're going to do a linear regression. And I would choose the choice that says ax plus b, or it may have different variables in the calculator. The goal is the x's first for your list. Okay, so you have keyed it in, and in my calculator the choice is y equals mx plus b, so that's what I chose. And I can see that my slope, or my m, is 6.321, so my m is going to be 6.32x, and then my b is 22.485. So plus b, 22.49. It says round to the nearest hundredth. Now the second problem says create a residual plot on the axis below. So you're only going to use your x variable, which is written on your graph, and your residual. Imagine that your raw test score is just gone for this. So we want to slide over here, and it says 1 and then 1.3, so you're estimating, and then 2 and 1.9, and 3 and -6.4. So you're really, they make it kind of nice for you because you're really just plotting points. 4 and -0.7, 5 and 2, 6 and 6.6, and 7 and -4.7. So there we go. Based on the residual plot, is it a good fit? I do not see a pattern. It does not look like a U or a V or anything. I'm going to say it does look like a good fit. Yes, there is no pattern to the residual plot. Okay, and our problem. On a standardized test, Kathy had a score of 74, which was 1 standard deviation below the mean. if the standard deviation for the test is 6, what is the mean score for the test? So you may want to refresh yourself with the concept of standard deviation. So if we have from 0 to 100, we'll have our 50. I'll make this really loose. So you've got 75 and 25. She had a score of 74. And that was one standard deviation below the mean. So the mean was kind of up here. And pretty much everything follows a bell curve. In our statistics we learned, so we'd have our bell curve. The standard deviation means that we are 6 points, like a certain percentage of kids, like about 50% of our kids are going to show up one standard deviation away from the mean. So she was 74, the standard deviation is 6, she's one standard deviation below the mean, so the mean would have been 80. She's 6 points below. So we will do a little more reviewing in detail with standard deviation, but for this question you just need to take that data. The standard deviation is 6, she's below it, and you add up. So that is the end of Regents Review 3.